Have you ever wondered if time travel is truly possible? What if we told you that scientists are actually working on it right now? Join us as we delve into the fascinating science behind time travel and explore the potential for bending the fabric of time itself. Time travel may seem like something out of science fiction, but it's actually a serious topic of scientific research. Get ready to have your mind blown as we uncover the groundbreaking theories and experiments that could make time travel a reality. The concept of time. What are we really talking about? Time is something we all experience, but few of us actually understand. Is time an illusion, a physical dimension, or simply a measure of change? Physicists view time not as a constant, but as something malleable, something that can speed up, slow down, or even loop back on itself under the right conditions. This changes the conversation from if time travel is possible to how it could be achieved. Our everyday experience tells us time flows forward, but what if that's just how we perceive it? Einstein once said that the distinction between past, present, and future is only a stubbornly persistent illusion. When we begin to think of time as a fourth dimension, it's just like length, width, and height, the doors to time travel start to creak open. Think of a timeline not as a straight line, but as a flexible thread. In certain conditions, such as extreme gravity or near light speeds, this thread might stretch, warp, or even fold. This idea is what gives rise to theoretical possibilities for time travel, manipulating the very fabric of space-time. This is the foundation of all time travel theories. Understanding time not as a fixed path, but as a dynamic terrain. Space can be curved, could time be curved too? And if so, could we find a way to navigate it like we do with GPS satellites? Just not around Earth, but around moments in history. Einstein's theory of relativity and time dilation, Albert Einstein, revolutionized our understanding of time with his theories of relativity. One key concept is time dilation, the idea that time passes at different rates depending on how fast you re-moving or how strong the gravitational field you re-in is. It sounds unbelievable, but it's already been proven. GPS satellites in orbit around Earth actually experience time a bit differently than we do on the ground. Their clocks run slightly faster because they're further from the Earth's gravity. This difference is so real that if we didn't correct for it, your phone's GPS would quickly become useless. It's time travel on a microscopic scale happening every day. Now imagine this effect magnified. What if you could travel close to the speed of light? According to relativity, time for you would slow down drastically compared to people on Earth. You could take a journey lasting a few years from your perspective, only to return and find that decades have passed here. This isn't science fiction, it's math. It's real physics. Relativity doesn't just predict these phenomena, it demands them. If we can build technology capable of sustaining such speeds or manipulating gravity, then time travel into the future becomes not just possible, but inevitable. Wormholes, shortcuts through space and time. Wormholes are theoretical tunnels in space-time, concept born out of Einstein's general relativity equations. Picture the universe as a two-dimensional sheet of paper. If you fold it and punch a hole through both layers, you've created a shortcut. This is essentially what a wormhole would be. In theory, wormholes could connect not just to points in space, but to moments in time. The idea is that if you enter a wormhole, you could emerge at a different time than you left. However, there's a catch. These structures, if they exist, are extremely unstable and likely microscopic in size. Scientists have proposed exotic matter substances with negative energy as a way to stabilize wormholes. The problem is that we haven't yet discovered how to produce or control exotic matter on a usable scale. Still, if we ever do, wormholes could become our best shot at true time travel. This concept isn't just confined to blackboards and sci-fi novels. NASA physicists have explored the math, and serious thinkers like Kip Thorne have contributed real equations to the discussion. The more we understand black holes, gravity, and the structure of the cosmos, the more plausible wormhole travel becomes. The grandfather paradox. Can you change the past? Time travel to the past raises one of the most famous paradoxes of all, the grandfather paradox. What happens if you go back in time and prevent your grandfather from meeting your grandmother? If they never meet, you're never born. But then how did you go back in time to begin with? This paradox challenges our very notion of causality. In a universe with linear cause and effect, changing the past should be impossible. But what if time isn't linear? Some scientists propose that every action creates a branching timeline. In this multiverse view, killing your grandfather just creates a new timeline where you were never born, while the original one still exists. This idea aligns with interpretations of quantum mechanics that allow for multiple realities existing simultaneously. If true, it means that going back in time doesn't alter your own timeline, but creates a new one. So paradoxes might not be problems, they might be signs of deeper truth. These mind-bending possibilities have real implications. If we ever develop time travel, understanding how timelines behave could determine everything from safety protocols to ethical guidelines. Will we be explorers or accidental destroyers of our own realities? Time loops and closed time-like curves. What if time travel doesn't just allow us to jump to the past, but traps us there? Physicists like Kurt Gödel and Kip Thorne have explored the idea of closed time-like curves paths through space-time that loop back onto themselves. Imagine taking a walk and ending up back at the exact moment you started. Such loops could allow time travelers to revisit the same events endlessly, but they also raise profound questions. You're stuck in a loop. Are you free to change events? Or are you doomed to repeat them forever? Does free will even exist in a time loop? These aren't just philosophical musings. Mathematically, general relativity allows for the possibility of such loops under specific conditions, usually involving massive rotating objects or certain configurations of spacetime. But no one knows for sure if the universe permits them in practice. If time loops do exist, they could hold the key to immortality or eternal imprisonment. They might allow us to learn from the past or force us to relive it indefinitely. Either way, understanding time loops could be essential for any future time travelers seeking control over their journeys. Quantum mechanics and the uncertainty of time at the quantum level, reality behaves in ways that seem to defy logic. Particles exist in multiple states until observed, and time itself appears blurry, uncertain, and even reversible. Unlike the predictable laws of classical physics, quantum mechanics opens a door to a more chaotic and more fascinating universe. One of the strangest implications of quantum mechanics is entanglement, where two particles remain connected no matter how far apart they are. Change one, and the other responds instantly. Some theorists suggest this spooky action might hold clues to time manipulation, possibly offering a way to transfer information or even matter across time. Then, there's the concept of quantum tunneling, where particles can seemingly pass through barriers instantaneously, almost as if skipping through time. These aren't just flukes of nature, they're repeatable, measurable, and fundamental to how atoms behave. If time can be bent or bypassed at the quantum level, could we one day scale this up? Quantum mechanics doesn't just challenge our understanding of time, it shatters it. In a universe where particles don't have a definite position or time until observed, could the observer also become a traveler? The implications are staggering, and science is only beginning to scratch the surface. The arrow of time. Why we remember the past, not the future time, seems to have a direction. We grow older, not younger. We remember yesterday, not tomorrow. This phenomenon is called the arrow of time, and it's deeply tied to the second law of thermodynamics, which states that entropy, or disorder, always increases. Entropy explains why eggs break but never unbreak, why coffee cools but never spontaneously heats up again. These processes all point in one direction forward, but while thermodynamics gives time its arrow, physics itself doesn't require time to move that way. The fundamental equations work the same whether time flows forward or backward. This raises a mind-bending question. Is the arrow of time just a product of our limited perception? If we lived in a universe with reversed entropy, would we experience time backwards and never know the difference? Understanding entropy's role in time travel is crucial. If we ever learn to manipulate entropy, perhaps reversing it in a localized area, it might become possible to reverse the flow of time itself. Not just metaphorically, but literally. Real experiments. Have we already bent time? Time travel isn't just a theory, it's been demonstrated on small scales. In 1971, the Haffel-Keating experiment flew atomic clocks around the world on commercial airliners. When they returned, the clocks showed slightly different times than identical ones left on the ground. Time had actually passed differently for them. Particle accelerators have pushed subatomic particles to near light speeds, extending their lifespans by slowing time for them. This is textbook time dilation, witnessed and measured repeatedly. These effects might be tiny, but they prove the concept. Time is not absolute. It's flexible, stretchable, and influenced by motion and gravity. Even more recently, scientists have managed to simulate quantum time reversal in small-scale systems. Though it's not sending anyone back to the past, it hints at the potential for manipulating time directionally, at least in controlled environments. These experiments are the stepping stones. They show that the building blocks of time travel are not fantasy, they're observable reality. The question is no longer if we can manipulate time, but how far we can push these effects. Time travel in popular culture, influence or distraction. From Back to the Future to Interstellar, time travel has been a beloved trope in movies and books. These stories have shaped how the public views time travel of fun in ways that blur the line between science and fiction. But has pop culture helped or hurt our understanding? On one hand, these portrayals inspire curiosity. They raise awareness of scientific concepts like wormholes, relativity, and alternate timelines. On the other hand, they often oversimplify or distort the reality. Time machines that jump to specific years with flashing lights are dramatic, but they gloss over the complex physics involved. However, science fiction has also predicted many technologies long before they existed. Think of video calls, tablets, or space stations. In that light, today's time travel stories might be tomorrow's reality. They serve as speculative roadmaps, planting ideas that scientists may one day bring to life. Ultimately, pop culture isn't a distraction, it's a spark. It opens the public's imagination to what science could eventually achieve. And sometimes, that's all innovation needs to begin. Ethical dilemmas of time travel. Let's say we invent time travel. Now what? Should we use it to change history? Prevent disasters? Save lives? The ethical questions are endless and deeply troubling. One small change in the past could create massive ripples in the future, a phenomenon often called the butterfly effect. Who gets to decide what should be changed? What if saving one person means another dies? What if we try to erase a tragedy, only to cause a greater one? These aren't just theoretical questions, they're dilemmas any time-traveling civilization would need to address. Then there's the issue of power. If time travel becomes possible, who controls it? Governments? Corporations? Private individuals? The potential for abuse is astronomical. Imagine someone going back in time to manipulate markets, elections, or even rewrite history to suit their agenda. Ethics might end up being the biggest challenge of all, because even if we solve the physics of time travel, we'll still need to solve the morality of Eitand that may prove far more complex. Could nature be protecting the timeline? Some scientists, including Stephen Hawking, propose that time travel might be impossible not because of technical limitations, but because the universe itself censors it. This idea is known as the chronology protection conjecture. According to this theory, any attempt to create closed time loops would be prevented by physical laws, perhaps by quantum instabilities or sudden bursts of radiation that destroy the wormhole before it can be used. In essence, the universe might have built-in safety mechanisms to prevent paradoxes. This concept suggests that time travel to the past may never be possible, not because we lack the tools, but because the fabric of reality won't allow it. It's like trying to divide by zero. Some actions might simply be illegal in the universal rulebook. But this idea is still theoretical. We don't yet know whether nature truly forbids time travel, or if we just haven't figured out how to do it. Until we try, we won't know if the timeline protects itself, if it's waiting for someone to break it. The future of time travel. What's next? Time travel might be in its infancy, but the future holds incredible promise. New discoveries in quantum physics, gravitational waves, and cosmology are bringing us closer to understanding how time works and how we might one day navigate it. Tech giants and academic institutions alike are pouring resources into advanced physics research. AI is accelerating discoveries, helping scientists simulate models of space-time that were once impossible to compute. Even if a full-fledged time machine remains out of reach, time-related technologies are evolving quickly. One area of interest is time perception. How we might augment or slow our internal sense of time through neural interfaces or brain-computer links. Another is time-based communication, sending signals or information backward across limited time frames. The timeline for building a working time machine remains unknown. But one thing is certain: we're closer than ever to understanding the mechanics of time. And with that understanding, the dream of traveling through it edges ever closer to reality. Time loops and the concept of eternal return, one of the most mind-bending ideas in time. Travel is the concept of time loop cycles where events repeat over and over. These are often depicted in films like Groundhog Day, but they also have roots in philosophy and theoretical physics. Could time itself be cyclical, looping endlessly instead of flowing linearly? The idea of eternal return goes back to ancient civilizations and was later popularized by Friedrich Nietzsche. It suggests that everything that happens has happened before and will happen again. In physics, similar ideas appear in theories about closed time-like curves, where the future loops back into the past in a seamless cycle. Some models in cosmology even propose a cyclic universe. In this view, the universe expands, contracts, and is reborn infinitely. If true, time itself could be a loop, with no real beginning or end. That would mean the concept of traveling through time is less about jumping along a line, and more about navigating a circle. These ideas aren't just philosophical, they have implications for how we understand causality, memory, and even consciousness. If time loops are real, we may have lived this exact moment countless times before. It might live it again, forever. Could time travel explain unsolved mysteries? Some people believe that time travelers might already be among us and that their presence could explain certain historical mysteries. From mysterious figures in old photographs to sudden technological leaps, there are countless stories that fuel speculation about visitors from the future. Consider the story of John Titor, a supposed time traveler, who appeared on internet forums in the early 2000s claiming to be from the year 2036. He offered detailed descriptions of his machine and made eerie predictions, some of which were disturbingly close to reality. Was he a hoax or a warning? Then, there are unsolved anomalies like the Antikythera mechanism, an ancient Greek device far more advanced than anything else from its time. Or the legends of Vimanas in Indian texts, described as flying machines with remarkable abilities. Could these be echoes of forgotten knowledge or something brought from the future? While mainstream science doesn't support these claims, they continue to captivate our imagination. What if time travelers operate in secret, observing without interfering? Or what if the evidence is all around us, waiting to be understood in a new light? The human desire to control time, why are we so obsessed with time travel? Maybe it's because time is the one thing we can't control. We can build machines, explore the cosmos, and even edit genes. But we can't stop time. We can't rewind it, pause it, or skip ahead. And that helplessness drives our deepest curiosity. The desire to revisit the past often comes from pain, regrets, losses, mistakes. Meanwhile, our urge to see the future stems from hope, curiosity, and the dream of something better. Time travel represents the ultimate form of power, the ability to rewrite your life, to gain perfect hindsight, or to glimpse what lies ahead. Philosophically, time travel forces us to confront uncomfortable truths. If we could change the past, would we still be ourselves? If we knew the future, would we live differently? These aren't just theoretical questions. They strike at the core of identity, free will, and meaning. In the end, the science of time travel is a mirror. It reflects our fears, our hopes, and our deepest longing to escape the limits of human existence. Whether or not we ever master time, the quest to do so reveals who we are and what we're willing to dream.